All right, hello, Algebra 2. This is Lesson 3.5, Applications of Linear Systems. You have this worksheet today. It's numbers 1 through 6. That's all you have to do. You do not have to do the whole thing. But, if you want extra practice, you can do the remaining problems as well for extra practice. It's totally up to you. We are doing applications, but these applications are really nice, and the practice that we're going to do right here in notes is going to be quite good for you to be able to do all of these applications yourself too. So for linear systems, we have two equations, and you can use either substitution or elimination to solve them. It's your choice. You can use whichever method you think will work best. We're probably mostly going to use elimination, but substitution would definitely work also. So whenever we have word problems, we want to figure out what we're trying to solve for. So the very first thing I like to do is actually figure out what the question is asking. So I want you to actually start at the end and answer the question, because this is what we're trying to find. How many pounds of apples and how many pounds of bananas did I buy? When you look at the question, that's going to tell you the algebra. It's going to tell us what our variables are. So we want to know, what are we trying to find? And it's right there in the question. And that also helps us figure out what our variables need to be. So we're going to let A equal the number of pounds of apples that I buy. And we're going to let B equal the number of pounds of bananas I buy. And this is always a good first step. It's called define your variables, and it comes from the question, really simply. Now, we're actually going to do some reading, and we're going to see if we can set up some equations. So the second step is to set up some equations. All right, now we can do that by reading carefully. All of these problems are very, very similar. And so you do want to probably write these problems down in your notes. I like to eat apples and bananas. Okay. And bananas cost $3 per pound. And apples cost $4 per pound. Well, they're giving me some information about cost per pound. That's good. So bananas cost $3 per pound, and apples cost $4 per every pound. Suppose I bought 12 pounds of fruit. I'm going to use a different color for that. 12 pounds of fruit. That's one equation. So if I'm only buying apples and bananas, special trip to the store, I bought 12 pounds of fruit. Well, I bought two different types of fruit. I bought apples and I bought bananas. I bought so many pounds of apples and so many pounds of bananas for a total of 12 pounds of fruit. All right. Then it says that I spent $41. So you'll notice here we have pounds of apples, we have pounds of bananas, and this is 12 total pounds. Okay, very important that all those units match. A, pounds of apples, B, pounds of bananas, and 12 pounds of fruit. Now I spent a total of $41. So now I have another equation that deals with money. So where do I have money in my equation? Well, bananas cost $3 per pound, okay? And that's really important. Do I put 3 for the bananas? No, it's $3 for every single pound. So if I buy 1 pound of bananas, it costs me $3. If I buy 2 pounds of bananas, it's 3 times 2. If I buy 4 pounds of bananas, it's 3 times 4. So it's 3 for every single pound of bananas. So anytime you see dollars per pound or something like that, you got to multiply by the number of pounds. And apples cost $4 per pound. $4 for every pound of bananas. So 4A plus 3B equals $41. $4 for each pound plus $3 for each pound gives us a total of $41. So you see how all of this talks about money, and all of this top equation is dealing with pounds. So paying attention to units can be very, very helpful. Now, this is a great system of equations, and we can solve this pretty easily just using some elimination. I'm going to go ahead and multiply this top equation by -3. That way I get some opposite values here. So I'm going to go ahead and distribute that -3 and rewrite. So I get -3A and a -3B equals -36 pounds of fruit. And that bottom equation I'm not changing. So 4A plus 3B equals 41. And then I can go ahead and total them up. Combine them, we get A, the bananas cancel out, and -36 and positive 41 is 5. So A equals 5. And then I can go and plug it in to this other equation. 5 plus B equals 12, so B must equal 7. So if a problem starts with words, it should end with words as well. So we bought 7, I bought 7 pounds of B for bananas and 5 pounds of A for apples. And this is why I like these applications, because we want the variables to have meaning. So I am never ever going to use X and Y, because I want to look at it and say, hey, B is for bananas and A is for apples. So we want to use meaningful variables. Okay. All right. So example 2, at the fair, the Ferris wheel ride takes 4 tickets per ride and the roller coaster takes 7 tickets per ride. Suppose I was able to take 12 rides total and used a total of 63 tickets. How many times did I ride on the Ferris wheel and how many times did I ride on the roller coaster? So the first thing I want to do is look to the question and say, what's the question asking? And that's going to help me define my variables. So I want to know how many times each did I ride on the Ferris wheel and that roller coaster. I'm going to use R. So I'm going to let F equal the number of rides on the Ferris wheel. I don't know if you know this, but it's called a Ferris wheel because the first person to ever make one, his last name was Ferris, Mr. Ferris. That's right. And then I'm going to let R equal the number of rides on the roller coaster. That's also why it's capitalized, is because it's actually his name. All right, there you go. Some little trivia. So the first thing we want to do is figure out what the question is asking. And so if we find F and find R, then we've answered the question. All right, now let's read what we've got here. I was able to take 12 rides total. 12 rides total. So I'm only riding on the Ferris wheel and the roller coaster because I have a thing for them. And so I made 12 rides. Well, I took F rides on the Ferris wheel and R rides on the roller coaster for a total of 12 rides. So number of Ferris wheel rides plus the number of roller coaster rides equals a total of 12 rides. Now let's talk tickets. So I have more information about the total number of tickets that I'm using. I have 63 total tickets. So now I need an equation that uses all the tickets. So it says the Ferris wheel was 4 tickets per ride. Every time I rode on the Ferris wheel, it cost me 4 tickets. So 4 tickets for every single ride. And the roller coaster took 7 tickets per ride. So every time I rode on the roller coaster, it cost me 7 tickets. So if I rode once, it was 7. If I rode twice, it was 14. If I rode 3 times, it was 21. All right. So here is a wonderful system. And I think I'm going to go ahead and I'm going to use elimination again. I'm going to go ahead. 4 is the smaller number, so I'm going to make this a negative 4. So I'm going to multiply by negative 4 and distribute. So that's going to be negative 4f minus 4r equals 12 times 4 is negative 48. I'm not changing that bottom equation. 4f plus 7r equals 63. And then I can go ahead and the f's make a 0. Negative 4 plus 7 is 3r equals, math I can't do without a calculator. 63 minus 48 is 15. Okay, 15. And then I can divide by 3. So r equals 5. And then I'm going to go back to my easy equation here. Let's see, f plus r was 5, equals 12. So f must be 7. All right. So I rode the Ferris wheel 7 times and the roller coaster 5 times. Okay. It's just a general rule of thumb. If the problem starts with words, then it should end with words. Okie dokie. So really here, this is the setup. And if you can see where we're getting these numbers and stuff right out of the problem, they're all pretty much this easy. All right, last one, a little bit different. There's only one of these on the worksheet. So example 3, a plane traveled 580 miles to Ankara, I think it's Ankara, and 580 miles back. 580 miles both ways. It's weird wording. The trip there with the wind. What happens when you're flying in an airplane and you're traveling with the wind? It makes you go a little bit faster. It gives you an extra little push, and that's important to understand. Took 5 hours. The trip back against the wind, which means it's slowing you down, took 10 hours. Find the speed of the plane in still air and the speed of the wind. So first we want to find, what is the question asking? We want to find the speed of the plane if air was not a factor, and what the speed of the wind was. So I'm going to let P equal the speed of the plane in still air. And we're going to let W equal the speed of the wind. And we're assuming here that the wind is remaining very, very constant and steady both the whole long trip. And also there are many, many ways to solve this, so you might know another way, and that's okay. So the other thing that is important to talk about here is that we have miles, which is a distance. We have hours, which is time. And we're trying to find speed, which is also known as a rate. So we have distance and rate and time, otherwise known as distance equals rate times time. And I hope you've seen that equation before, but distance equals rate times time is a very important equation that we want to understand. The other thing I have here is that I'm trying to find the speed. And so I think what I want to do is I want to get this rate or the speed, I want to get it by itself. So I'm going to divide by t. So I get rate equals distance over time, which makes sense when you think about a car. When you're driving down the highway and you're going 75 miles per hour. So that is your speed in miles per hour, and that makes sense. So a rate, or your speed, is miles per hour. What we're going to do is we're going to set up a nice little chart. So rate equals distance over time. And I like setting these little charts up. I think they're nice. All right, so I have two things happening. We have our plane that's flying with the wind. And then on the trip back, we're flying against the wind. Okay, and we want to try and find the speed of both things. So our rate, when we're traveling with the wind, our plane is going a certain speed, P speed, but because we're going with the wind is giving us an extra little boost, whatever that speed of the wind was. And so overall, our rate is just a little bit faster when we're going to Ankara. When we're going against the wind, our plane is going a particular speed, but because we're heading into the wind is slowing us down. So our speed, our overall speed, gets decreased a little bit by the wind. And that's something we really, kind of a nice thing about this. These equations are pretty easy. So let's see. Our plane traveled 580 miles. So our distance was 580 miles. They're with the wind in 5 hours. So it took 580 miles in 5 hours. And the trip back against the wind took 10 hours. So that was 580 miles in 10 hours. Distance over time. So we get these two equations, which are pretty nice. P plus W equals, it turns out that 580 divided by 5 is 116. And P minus W, 580 divided by 10 miles per hour is just 58. So here is our little system of equations, and this is a super nice one. Positive W, negative W goes away. So we get 2P equals, more math I can't do in my head, 116 plus 58, 174. And then we can divide by 2, and we get 87. Wow, that was one really slow plane. All right, and then I can take my 87 and I can plug it in, and I'm going to plug it into the top equation. So 87 plus W equals 116. And then I can go ahead and subtract 87. 116 minus 87 is 29. So the wind speed was 29. And it is a speed, and the units are going to be miles per hour. And that's important. All right, so the plane in still air flew in at 87 miles per hour, and the wind was 29 miles per hour. That's a really inefficient trip. That's kind of unrealistic. Usually a plane is flying in the hundreds of miles per hour, not 87 miles per hour. But whatever. It's just for practice. So folks, there you go. Have a great day, and make sure you submit this to Student View when you're done. Folks, have a great day.